Lily kills herself
Woohoo.
driving. Okay, so here we are. So I just opened up a new experiment here. But what I'm going to show you is how we do stuff. So I'm just going to the tools to use Shuffle Tester because I think it's the easiest way to show you how everything works. All right,
So, so,
so
so let's start with talking about why people would want to use the shuffle function.
I mean, you want to shuffle because you don't want to do what PowerPoint does, right? Like that's the main gist of what it is we're getting above something like
You want to
PowerPoint.
be able
We want
to,
to
so you
do,
want to be able to randomize the order of whatever it is you're trying to present to your participants.
yeah, and you want to do it in a structured way. So that's, I guess, a lot of the work I've done is trying to set it up so you can set up groups of items. So it's like these first 4 items are basically like, male faces, and the next 4 are female faces. And you want to be able to reliably say, I need to see a male face and then a female face, or I need to see a repetition of this face. Like, I need to see face 2 twice in a row. But what you don't want to have to do is set up a whole bunch of different orderings to try to counterbalance these things on your own. So instead, you can just treat the items like groups of items, and within the groups you can have them shuffle at random per participant and
Okay,
do
so
it
let
that
me just
way.
let me just repeat in terms of a concrete example of what someone might want to do then. So the very, very first level is just basic randomization. You have a set of, you're using female faces, for example. You have 5 different women, and you want to show people these women's faces, but in a random order for every individual. So that's the first level of shuffling. But let's say now you want to show people also male faces, but you want all the male faces to be grouped together in a random order, and then all the female faces to be grouped together in a random order. Now, sometimes you want the male faces to come first, and sometimes you want the female faces to come first. And so the second level of shuffling is what allows you to counterbalance or randomize which gender set of faces appears first.
Yes.
Would that be the second
Although,
or third level of shuffling now?
what was it, Derek?
Would that be the second or the third level of shuffling, right? Because the first level of shuffling would just be shuffling male faces, and then you would want to shuffle male and female faces separately, but then you'd also want to be able to swap the orders between the blocks of the male and female faces.
So that's
So
actually
the
only 2
shuffling,
levels.
that's 2.
That's
Yeah.
still okay. So you would still lump those up into 2 separate levels. Okay.
Yeah, so here I pulled up this little sheet which is like can kind of approximate this example. So we have the first 4, like, so what this shows you here is a shuffle tester, and it shows you here's what the thing looks like in the file you actually have, and right next to it says here's what it happens after we run it through the shuffles. So this is really good to verify that it's doing what you want to do. So in this case, right now it's doing nothing, right? So we have A, B, C, D is the order, and then 1, 2, 3, 4, and you can see the after is the exact same. And the reason it's the same is because in the shuffle 1 column, I have the pound sign there, which is just a shorthand for off. In fact, anything that contains a pound sign means don't shuffle it. So I could do something like, random characters, or let's just write Mikey and a pound sign. So I put that there, I can save it. I hit shuffle again. You can see that's still working the same way. So it's still A, B, C, D, 1, 2, 3, 4. So the first level when we're talking about like we want to group male faces together. So let's say A, B, C, D, these are the male faces. For the shuffle, you just give it a group name. So we can just write, wow, it's the keys there. So I can write male for the first 4. Save that, and then shuffle again. Now here on the left, you can see A, B, C, D are labeled male as we set it up. But on the right side, after they're shuffled, they're treated as a group, and so they're randomized. And now the ordering is B, C, D, A. And this is going to be random for every single participant who logs in. Will get a unique randomization, so it's not a this happens once and you're done. So if I hit shuffle again, you can just see here's another example. B, A, D, C, A, B, C, D, B, C, D, A. Yeah, so you get the idea, right? Like these first 4 here are essentially a group, and everything else is left alone.
Okay.
So you can equally just type in the word off, right? Instead of using the pound sign, would that also work?
Yeah, you can also type off. So if I change this to off,
And it
then
doesn't have
save
to
it.
be all caps. It can be low caps, mexo caps.
Yeah, it's not case sensitive. In fact, it's kind of an old hack that we designed. So that has an uppercase F, the second F. We'll see here if
Are
I
any
hit
of the
shuffle.
shuffles case sensitive?
Are any of the what?
Are any of the shuffles case sensitive? Like if you wrote Mikey with a capital M, would that be different from Mikey with a lowercase m?
I don't think so, but let's test.
Try to.
I'm keeping notes, by the way, so that way for the documentation later. So that's why I'm asking so many questions.
Good. Questions are good. Okay, so this is a capital Mikey and a lowercase Mikey. So if these are case sensitive, then all these will end up mixed up. If they're not case sensitive, then we should have this group mixing up. So the A, B, C, D will be the first four, and then the 1, 2, 3, 4 will be the second four, although both those groups will not be in that order. So let's see what happens. And it's case sensitive. It looks like it cares. Good thing to know. Yeah, so the off thing, the only reason it's in there is kind of an old hack. Like, yeah, it's really not really worth getting into, but usually I just tell people the pound sign's a lot more reliable.
Well, the off makes intuitive sense too,
Yeah.
right? So the pound sign means something to you coders, but not necessarily to other people.
Yeah. So the off is the only case you wouldn't want to use the off is when you are sorry, I'm typing a thing. When you need multiple groups to be turned off, but not treated as one continuous group. So it's a weird edge
Wait,
case.
say that again?
What do you mean?
So you need off when you want, let's say the first four items you want them to not be shuffled. Like here in this case, instead of male, I can write off. And that would give me A, B, C, D will always be in this set order. And then afterwards it's going to say, these 1, 2, 3, 4s will get mixed up. And you can see this. So when I hit shuffle, right, so on the left is always the same. It's the before. But here, A, B, C, D did not shuffle. And 1, 2, 3, 4 did shuffle. So that's what off is doing here. Actually, before we get into multiple offs, we should talk about the second level, because that's the only case you really need it.
Okay.
So here, let's just say, okay, back to the kind of simple case. So we have 4 that are male, 4 that are female, hit shuffle, and you can see, these first 4 end up A, B, C, D, 1, 2, 3, 4. Although this happened to end up in the exact right order, which is a thing to note, that random means truly random. Like, I don't put constraints on it. I don't make sure things end up even. So like in the case Veronica talked about or even here, this is a really good case. So if I want to swap the male and female faces, let's say I don't want male to always come first, and I don't want to have to make a separate counterbalance order, I could rely on randomness. And the way I do that is by using the next level of shuffling. So at shuffle 1, so what happens when you have a shuffle 2 is you say, okay, here's another grouping of items. So here it's essentially all the items. So I'm just going to write faces. Right, so now the shuffle 2 says faces. And what that means is the code literally goes down shuffle 2 and looks for it to change. And here it hits the end and says nothing's changed. And so what that tells it is that all these items are in the same group, and that group is the faces group. And then this thing essentially looks to the left and says, how many subgroups do I have? So faces has a male subgroup with 4 names, or with 4 items, and a female subgroup with 4 items. So what that means is that these 2 blocks of items will be randomly shuffled about each other. So half the time male will come first, half the time female will come first, over a long run of time. But if you run a study with like 20 participants, you're not guaranteed to get 10 male and 10 male first and 10 female first. It is truly random. So that's
So
always
on a
thing to think
design
about.
note, so on a research design note, if you only have such a simple case, for example, 2 categories here, then that would actually be a good candidate to counterbalance rather than block shuffle.
Yeah.
If,
that's
however,
usually what I
you
tell
have,
people.
let's say, 20 different categories you're trying to teach people and you want it to always be in a random order, then it makes a lot more sense to randomize that than it is to tediously try to counterbalance all 20 categories.
Yeah, that's
Now,
usually what I would tell people.
So my next question, Mikey, is let's say I want a specific order of the male faces and of the female faces. So for example, I always want Derek's face to come up first.
Mhm.
How would you do that?
Okay, so here's how. So you want only his first and the others randomized?
or I want it in a very specific order. Or actually, let's talk about the one where it's in a very specific order. No first level randomization, only second level randomization.
Okay.
And then we can talk about the thing you just suggested.
Okay. So yeah, so if you want these, like let's say the order right here, A, B, C, D. Let's say it's a sequence of faces. Like you want people to see, like it's an animation of emotions. You know, they go from one state to another, to another, to another, and that ordering is important to your experiment. So you don't want to mess with that stuff. But you still need this to be in a group, right? Because you're here. Let's pretend this isn't just male and female, but there's different, characters you're looking at. There's 12 different characters, and you want to randomly pick one of those characters, but within each character, the ordering of their pictures or whatever stimuli you're using, you want to have set. So what you do is in these shuffle one columns, you could keep male and just add that pound sign. And this is actually why you want to use the pound sign instead of off. What we're doing here, is saying this group is a group and this is another group. Both these groups are stable, but they're separate from each other. Because if we just did off, the program would look and say, all 8 of your items are off items. So now this faces group wouldn't do anything here, because it would look down and say, well, there's only one group, there's nothing to be done. So, yeah, the old way we used to do it is that we was basically a hack, and you could do different casing of off. So this is technically a separate group. If I do,
that is so much cleaner. I love that.
Yeah, this is how you used to have to do it. Is say, well, these are separate groups now because the casing matters.
So
But
the
instead-
second level of shuffling, does it have to be contiguous? Do all of the faces items have to be next to each other, or can they be broken up?
At the second level, they have to be continuous. In
Okay.
fact, that's really important. And not even at the second level, everything but the first level has to be continuous.
Okay.
Because of this constraint that I essentially put on top of everything. And so I'll show you here. So here's the setup we just talked about. So A, B, C, D in one order within that little block. 1, 2, 3, 4 in that order. But whether or not the letters come first or the numbers come first will vary because of this second shuffle group. So faces groups these things together. So if we do this, now A, B, C, D here on the left, 1, 2, 3, 4. And then on the right, we get 1, 2, 3, 4 first, and then A, B, C, D. And if we keep hitting this, now letters are first, letters first again, numbers first. So you can see how these two are basically swapping positions. And if you had more groupings, like, let's just make this file a little bigger. So 1, 2, 3, 4. And this will be random text. Make it easier. Now we have a faces group that has 3 subgroups.
Yes.
And let's say we want the female faces for some reason to shuffle. So now we're doing a complicated mix of, well, the female faces don't have an ordering, but these male faces have an order, the other faces have an order. And so I want these 3 blocks to be moved randomly. I don't want to know which is coming first, which is second, which is third, but I know when it's the female block, the ordering can be randomized. When it's the male block, the ordering is set. When it's the other block, the ordering is set. So now if I hit shuffle, you can see our file grew on the left. And on the right, it went other, female, male. Other is in the exact ordering that it is on the left within that little block. The females are in random order because that group was allowed to randomize itself. And the male group is A, B, C, D because we told it to keep those items fixed.
All right. So at this point, people might be wondering to themselves, like, what if I want to separate out the male and the female faces and not have it continuous? Well, the solution for that is to do the block shuffling or the second order shuffling in your stimuli file, not in your procedure file.
Yeah. So both files shuffle, which is, I mean, it adds a lot of power, but it's another level of complexity to think about. But, I mean, in essence, the shuffling works exactly the same in both cases. Like, it's the exact same code running on the same spreadsheet, so it just depends how much you need. But what's nice about the shuffles is that this can technically go forever. So if I just add another column, so I have shuffle 2, now I have shuffle 3, and it's called body parts. let's say this study isn't just about male, female faces. Let's say you're recognizing all types of body parts from men and women. So I'm going to copy all these stimuli here. So it's the same filler junk because I'm too lazy to change it. But now instead of a faces group, let's call this hands.
So
A
Mike,
group of their hands.
when you get the chance, quick question: do all the blocks have to be the same size?
They don't have to be, but things become unpredictable if they are not. In unpredictable,
How so?
so if let's say you have 6 items in one group, and you have 10 items in another group. So if the 6 items come first, then item 6, or actually it's easiest to talk about item 7. So let's say the first 6 items show up, they're whatever, the smaller group. Item 7 is the other grouping, the group of 10. But now if they shuffle at random and they switch, item 7 is now the same group as item 6, and it wasn't true before. So just from the fact that they're different sizes means that when they move around each other, it becomes unpredictable, the relationship of the groupings between items 6 and 7.
So do you think that we might want to throw an error if the blocks are or the groups are of different sizes? Because I made that mistake the other day, which is why I asked.
So you could. So there's actually a solution for it, and it just ends up being more of this stuff. So let's say here, right, we have even size groups. There's male, female, and other. But let's say our male and female groups, we just have more stimuli for them, right? So we have an extra 2 stimuli for each of these. So here we're not going to do anything fancy. We're just going to say, well, these have 6 pictures, so I'll copy this line. E and F, so that's got 6. The female has 6. So let me copy those. And now other only has 4. So so if we want to randomize these, this becomes a problem because now other can't move essentially, right? Because it makes everything unpredictable. So we could do this. Is this what I've done in the past? I'll just do like, oh wait, Excel doesn't like that. So let's just call it filler. So in this case, I'm going to call this one. So above the male, what I'm doing is essentially grouping these again. I'm saying these male faces go together, and they're part of the male group. These female groups go together, and they're part of the female group. These others go together, but let's say I want these ones to be randomized. So the first 4, like the real stimuli, it's like, okay, well, I want those to show up.
Mm-hmm.
But above them, I don't want these two, I have essentially here 2 different groups. I have a group that says, don't shuffle these, so the last 2 items of the 6 stay in place. The first 4 can move, but because they're all part of this larger other group at the next level, they'll move together as a block of 6.
Okay.
So
but what if you don't want to present those last 2? Doesn't that force you to have to show those last 2?
No, you don't have to. So I did this actually. A lot of the reason I designed it was to do this. Is that I had item sets of different sizes, and so what I did instead of just usually what people do is equate the 2, right? They'd say, well, I have 8 items of this type, and these other types I have 10, so I'll just throw out 2 and use 8. Mm-hmm. So instead, what I did is I said, okay, well, in both groups I'm only going to use 8, but from the group of 10, I'm going to allow the entire group of 10 to shuffle and then pick the first 8. And from the other group, I'm just going to shuffle the first 8 and have the last 2 fixed as filler items. So I know I'm never going to use them. But they're essentially just stand-in, so I'm still sampling from my set of 10 items in one grouping, and I'm sampling from my set of 8 items, essentially sampling all of them.
But you don't know, because that other group now, it could be in the first third of the, it could be the first third, it could be the middle third, or it could be that last third. Right?
Yeah, so it ends up not mattering as long as you treat every group as if they only have 8.
Oh, as if they only had 8, I see.
Yeah, so I essentially never use 9 and 10, but the items that are put in 9 and 10 could end up in the earlier positions and get used in the study. So I didn't have to just
let's say let's say that you're now running a study where you want to show people multiple categories. So let's say one category is fruit, another category is drink, another category is occupation. Mm-hmm. But you want to show different numbers of stimuli from each category because you want the number of categories, the size of each category set to be unpredictable.
Oh, I see what you're saying.
Yeah. So does that mean for whatever category, let's say you intend to only show 3 flowers,
Mm-hmm.
Three, what did I say, 3 fruits,
Yeah.
3 drinks, and then 10 occupations. Does that mean that all your categories in your Stimly file have to have 10 examples?
I would do it that way. It's the easiest way to do it. Well, they don't have to be real examples, but I just make the blocks 10 long and then just fill
All
the
10
back end
long.
with fillers.
Okay, but now because you don't know whether that large real 10 block category of occupations, whether that's in the first third, second third, or last third,
Mhm.
you don't know how you should call upon those in your procedure file.
Well, if
Because
they're
if
the
you
only
call
group
the
that are they the only group that's 10 items long? So you're saying you just don't have
no, like
10
let's
stimuli,
say
or you just
you
want to use 10?
so yeah, let's say you can extend that. You have 20 different categories and you want them to all have different sizes.
From the participant's perspective, right? The participant sees
Right.
less of the examples or more of the examples.
Yeah.
Yeah.
But you want those sets, those different categories, to be randomly presented to each participant.
Mhm.
If your blocks have to be the same size, then you can no longer do that shuffling. You'll have to do a pseudo-randomization and maybe do one or 2 orders of that pseudo-randomization for each individual.
So I think you can actually do so let me be clear, I guess. I think that what you're asking for is possible. Like if I had 20 categories and there's 10 items of each, but I want to show different amounts to participants, or even let's say I have 20 of some items, 18 of others, 16 of others, you could essentially use the same strategy I'm using here of saying, okay, here are the things that will be randomized. Now basically all the blocks are the same size. Now move the blocks around at random, and then you can just have the procedure file say, okay, well, I want to pull 3 items for whatever ended up being the first of the categories. Like after I shuffle the 20 categories, 1 comes out first. So I would just say, well, use items 2, 3, and 4, because I know those will always be real items from the first category. And because I know their sizes, I know exactly where the category's in, so I could say, well, the next item comes up at 21 is the next category. That's where it starts.
So the only thing you can't do is say, I always want occupations to have this number of items and fruit to have this number of items, which ideally in an experiment you might not want to do anyways because you want to be able to randomize everything. That the 10-item category could be any of the categories.
Yeah, although you could even separate them out by category size, right? Like shuffle 2 could be 10-item blocks, and then there's 3 different categories that shuffle within that are, have 10 items, and they shuffle. Now those first 3 are predictable on where they're going to be, right?
Yeah,
2 through...
but then you can't randomize the order in which those different category sets get randomized. So then you can't say sometimes a 2-category block will come up first, other times a 10-item category block will come up next.
Yeah, so you do that on the procedure end. Pretty much once you set up on the procedure side, you're like, okay, well, I know where I'm sampling from. Like the
but
first
on the
3
procedure
items...
side, the block shuffle works the same way, so you can't have uneven blocks, which you would have to have in the procedure side.
Oh no, on the procedure side, you can have uneven. So it's not that you can have uneven blocks; it's that things get unpredictable as far as where items are going to be. But if in the procedure, let's say the first 3 trials are the short category.
Oh, I see. Okay.
The next 5 are a medium category. Then there's the next 10 are the long category.
I see.
You could just label each of those 3, then 5, and then 10, and then the next level could just be called practice, and they would randomly move those blocks around each other.
Okay, so the only place it would matter is when you're doing it in the stimuli file and you don't know what you're calling upon. That makes perfect sense to me.
Yeah, because in stimuli, that's the thing. Is the stimuli has to be hierarchical, because if not, it's unpredictable is where things are going to end up.
Okay.
So yeah, using these kind of weird little hacky things. So I still haven't even shown what this does. But right, we can kind of walk ourselves through how this would work. We'd imagine... So actually, I'll show you exactly what the code is doing, because I think that makes it the most clear. Because that's where one of the weird constraints comes in. So here, what the code does actually is it just starts at shuffle 1 and says, do you have a shuffle 1 column? If you do, it says, do you have a shuffle 2? And then it just keeps looking for the highest one it can find. So here it hits shuffle 3 and goes, okay, that's the end. Then it starts walking down this and looking for a change. It says, okay, the group is called body parts. the first item here is included in body parts, and it just keeps doing this, essentially. It's saying, wait for body parts to not be the group. If it hits a change in the middle, well, let's just do it in this case, actually. So it goes to the end and says, okay, well, body parts is now changed to there's no more items, so this is the group that I'm working with. Essentially, like, this highlighted stuff is now all that it knows about. And it says, okay, now, based on that, look at these groupings, and it says, okay, I see a male group, I see a female group, and I see, oh, those are so close. It says I see a male group, a female group, and I see an other group. And now these three get moved around at random. So let's pretend that I did randomness, and then I got this. Oh, wait, come on. Cut. And paste. There we go. So let's say randomness gave me this, and this is what this is what the code does next. So now it's done with shuffle 3. It just essentially says, okay, I've grouped these things, move them around, now start again from this subgroup. And it walks down and says, okay, I'm in female. Wait for female to change. Nope. Sorry, so these are all getting included. And then it says, oh, female has changed now. And then it looks to shuffle 1 and says, do whatever you have to do here. So shuffle 1 tells it, well, items 1 through 6 should all get mixed up together, and they will get mixed up. So what you couldn't do here, so this is the one weird constraint. So in shuffle 1, it doesn't know anything about the other items that aren't in its group, right? So we started with, here's a big group, then we shuffled the block 2, and now block 2 says, this is all I know about in the world. I know about these items. So number 1, 2, 3, 4, 5, 6 will never mix with these items because they have a different parent group.
Okay.
So it's always looking downwards. It's essentially saying, start from the top, wait for a change, and once we change, that's all I know about. So if this, became a non-word there, right? Eyes, I don't know. If that became that, then even if these were all called female, right? So if this was just nothing but the shuffle 1 just said female, these items would not mix. They would still be separated because they're in different parent groups. So you can't bounce items from here to there. Because when this shuffling happens, it's already been cordoned off from every other item. So I built it to try to maintain, try to make it very hard for you to break groups.
Okay.
And the groups are always from the top down. So we could also build it from the bottom up. I don't know, Adam prefers that, but I feel like that confuses me more. But I mean, it wouldn't be that hard to do it the other way. But this is the one weird constraint that I tell people about.
If you really wanted to break up the groups, you could put one form of shuffling in the stimuli and another one in the procedure, and that would allow for that.
Yeah, usually, I try to, stimuli are usually better like this, hierarchical, right? We have 10 of these type of faces, 10 of those types of faces, and then of each of those subgroups, there's, they split amongst 4 other subgroups. Of each of those, they split left and right or whatever. So I very much think of it like a tree. Oh, well, I guess an upside-down tree, right? The top is shuffle 3, and then it just keeps breaking down. So it's more like the roots than the tree. Trees are symmetrical. In theory. Yeah, so this is the weird constraint that I don't know how to tell people about, but it's there. It's definitely going to do stuff. Like here, if we're looking at, oh god, why didn't it want to do that? Oh, it's because I hit no. Excel always wants to save it in its own format. Right, so here we have body parts. These are male, these are female. So this actually would try to shuffle these subblocks, but the problem is there's only one subblock, so it doesn't do anything, right? So this doesn't work any differently than that. Because when you have a second level, actually, it makes more sense to show you like this, because this other group has that exactly. So other has 4 items that are real, 2 items that should always be last because we're never going to use them.
Mm-hmm.
And there we go. 4 others, 2 fillers. So as long as we sample the first 4 from each of the categories, we are guaranteed to get a real item, even though one of our categories has less items than the other. Because we've treated this as if it's a block of 6, and that's a block of 6, and that's a block of 6. Then we can know predictably the first 4 items of each of these groupings, so 2 through 5, or I guess 8 through 11, 14 through 17. Those are all going to be real items, no matter how the shuffling works. So if I hit shuffle again, I guess I can make it bigger. So you can see every time I hit this, these are always real items every time. And this is just generally good practice for like whenever you're looking at your own studies, I do this a bunch. And this is a cool little tool. So if you can zoom out, like if it's a huge sheet, you can do this.
Oh,
Or if you have a bunch of content that you can't read, so if you hover it, if you look right here, the content actually changes as I hover. So it kind of acts as that preview in Excel. And if you hover away, it goes away, right? It keeps changing. But you can lock it into, so let's say this cell had a bunch of content. If I click it, turns gold. Now it doesn't matter where I mouse. It shows me there. I can grab this little corner and make it bigger. So if you have like a passage or something, reset, it just puts it back how it's supposed to be. Yeah, so I think that's the most complicated thing about shuffles, is the fact that you can't jump across higher order groups. And it was by design, but I don't know if people wanted that, but I know I'm always afraid that I'm going to do that.
Okay. Do we maybe want to talk about the procedure file in relation to the stimuli file?
I don't think we should. So I guess this is how I see it. I think people should just get how shuffles work, and then we can like more broadly just introduce procedure and stim, and maybe have it a separate video. Just like here's really complicated things you can do when you combine shuffling on both.
Sure, but I just mean it's kind of hard for them to introduce the stimuli file concept without introducing how you would actually call upon anything in the stim file.
Oh yeah, so yeah, this is not designed to teach anyone any of that stuff. Like I think I'm gonna show like the idea is to make another video just showing like here's how procedure and stim work.
Okay.
And then just basically say yeah, and you can shuffle them, and we'll talk about like what shuffling does, and then maybe make another video showing like examples of like here's a design you can achieve by shuffling stuff instead of trying to counterbalance everything.
Okay. So you're trying to treat those two as separate concepts, so to the point where they get their own Wikipedia page or whatever Pedia page we're using. You want those to be two separate articles, stimuli, and then the procedure file shuffles.
I mean, I think the shuffle should be treated the same, but I think so I've talked to Tyson, he said usually the best success he has is teaching people just the procedure file, like not even talking about the stim, just saying, look at these procedures, look how it's basically the instructions you give it, and he'll just do like a series of instruction trials and show people, look I typed in this thing and it shows up second on screen. And then once he goes beyond that, he starts saying, okay, and there's a stimuli file and you can reference it with items.
Okay.
But yeah, I mean, it's up to you guys, whatever's the most clear to the users, because I mean, I've worked with it too much to really have any sense of what makes sense.
I think it's useful if it's in a separate video, just because it's really already quite long, and for people to scroll through can be difficult.
Yeah.
So I think smaller bite-sized chunks, and I think we have a lot of bites already in this one.
Yeah, and this will probably end up being a thing where you guys distill it down to some document, we make a small script, and then just record like a person clicking those things and then just saying whatever that script is.
Solid. Can do.
Yeah, but does this clear up like some of your questions, Veronica? Because I know you're the
Yes,
more familiar
totally
with that
does.
stuff and what we're doing now.
Yes, it does.
Okay, yeah, so this should be a lot easier than what we used to have to do, because it used to be a pain to get lots of this stuff working.
I love the pound sign.
Yeah, the silly off casing. You were actually hard limited. You could only have 8 groups because there's only 8 permutations of ways you can case the word off. Which is literally the problem I had to solve, because I'm like, I have 12 groups. I now need to rewrite my shuffle because I finally hit the limits of my weird hacky solutions. So this lets you do all kinds of crazy crap. And this is infinite. Like, you can make shuffle 100. Although if you throw one out, it won't find the next.
What do you mean if you throw one out?
So if I deleted shuffle 2, or if I wrote shuffle space and didn't write 2, it'll say, do you have shuffle 1? Yes. Do you have 2? No. And then stop looking.
Okay, so
that's the thing we're probably going to add an error check.
Shuffle and then the number immediately after with no space. So shuffle
No,
1,
with the space.
Shuffle 2. Oh, with a space. So shuffle
Yeah.
1, shuffle 2, shuffle 3. Okay.
Yeah.
I think
that's
that
why
was
I always
something
tell
that
people-
also confused me, because we've gone through so many different permutations of how to label those columns.
Yeah, so that's actually one of the things we fixed in Dev, is that we've simplified it in that now we don't do camel cases on anything. So all the columns that have two names are two words, because it used to be inconsistent. Like sometimes we
Did you
camel
say
case, sometimes you
camel
put
case?
spaces. Yeah, camel case is this. It's so like Mikey, or actually, yeah, Mikey Garcia.
It's got a hump in the middle,
Yeah, like a camel.
like camel.
Okay.
Programmers know camel case.
Yeah.
Okay.
Yeah, so
Okay.
we don't camel
Got
case
it.
anymore. Now we do whole word space something. So like
Okay,
post one is how you do post space one is post trial, or
Got it.
min time with a space, or max time. So it's a lot more consistent, but it does take some re-educating from breaking people of the bad habits we established earlier.
Cool.
Okay.
All right, cool. That's all.
All right.
All right, take care, people.
Bye.
Peace. Bye,
Yeah.
Veronica.
Bye.
Bye.